Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving into a fascinating topic, reasoning language models, specifically outlining a potential blueprint.
Yeah, it's exciting. We've seen these language models get incredibly good at generating text, but the big question is, are they really reasoning or just cleverly mimicking it?
That's exactly the problem. It feels like we're building these incredibly complex systems that are great at pattern recognition, but they lack any real understanding of what they're saying. They're parrots, not philosophers.
I agree with Sarah. To me, they feel like a sophisticated brute force approach. They can predict the next word in a sequence with impressive accuracy, but they don't seem to grasp the underlying concepts or relationships. The ability to translate between representational coordinate spaces is missing entirely. So how can true reasoning arise?
So let's unpack this blueprint idea. The promise is that by scaling up language models and tweaking their architecture, we can unlock genuine reasoning abilities. What are your initial thoughts on that approach, Otto?
Well, I'm optimistic. We've seen the incredible progress in recent years just by scaling up models and datasets. Think about GPT-3, then Lambda, and now these even larger models. The improvements have been dramatic. And I think that if we keep pushing in that direction, we'll eventually reach a point where these models exhibit something that we can legitimately call reasoning.
I'm much more skeptical. I think that simply throwing more data and more layers at the problem isn't going to solve it. We need a fundamental shift in how we represent knowledge and how we enable these systems to reason with that knowledge. More like neuro-symbolic systems, maybe?
Exactly. It's like trying to build a bridge by just piling up more and more dirt. At some point, you need to start thinking about architecture and engineering principles. These models are fantastic at recognizing correlations, but true reasoning requires understanding causality and the ability to abstract away from specific instances. The ability to translate between the representations of the coordinate spaces is the key.
But isn't the ability to identify subtle correlations and patterns a crucial step in the reasoning process? I mean, consider how scientists develop hypotheses. They often start by noticing patterns in data, and then they develop a theory to explain those patterns. These language models are incredibly good at identifying patterns, so couldn't they be used to generate new hypotheses in scientific domains?
That's an interesting point, Otto. Could these models, particularly when trained on massive data sets of scientific literature, essentially act as hypothesis generators for human researchers? Think of a language agent trained on all of theoretical physics.
The issue with using them in that way, though, is that we wouldn't necessarily know why the model generated a particular hypothesis. It's a black box. And if we can't understand the reasoning behind a hypothesis, how can we properly evaluate it? We could end up chasing down dead ends based on spurious correlations.
And it's not just about generating hypotheses. It's about testing them, refining them, and integrating them into a coherent understanding of the world. That requires a level of understanding that I don't think these models currently possess. How can you test a hypothesis about spatiotemporal dynamics without understanding how to translate between the different coordinate representations?
Okay, but let's say we can find ways to make these models more transparent. What if we could develop techniques to visualize the internal representations of these models and understand how they're making decisions? Wouldn't that address some of the concerns about explainability?
There's definitely a push in that direction with research into techniques like attention mechanisms and concept activation vectors. The idea is to open up the black box and see what the network is focusing on when it makes a prediction. But even if we can visualize attention, does that really equate to understanding?
I don't think so. Attention mechanisms might tell us which parts of the input the model is focusing on, but they don't tell us why it's focusing on those parts or what kind of reasoning it's using to connect them. It's still just a correlation, not an explanation. Explainable AI is not there yet.
Exactly. It's like looking at the wiring diagram of a computer. You can see all the connections, but that doesn't tell you what the computer is doing or why it's doing it. You need to understand the underlying algorithms and the logic of the program. You need to understand the coordinate frames that the model is translating in order to understand the logic.
All right, so maybe explainability is still a challenge. But what about the potential for these models to augment human reasoning? Even if they're not perfect reasoners themselves, could they still be valuable tools for helping us solve complex problems?
I think that's a very realistic and promising application. Consider using language models to summarize complex scientific papers, identify relevant information, and even suggest potential connections that a human researcher might miss. It is like having a research assistant that has read all the science papers.
That could be useful, but we need to be careful about relying too heavily on these models. If we start outsourcing our critical thinking to AI, we risk becoming intellectually lazy. And if the models are biased or flawed, they could lead us down the wrong path. It's garbage in, garbage out.
And again, it comes down to the lack of understanding. If the model suggests a connection between two concepts, we need to be able to evaluate that connection critically. We can't just blindly accept it because the AI said so. We need to see how the coordinate frames of the two concepts are translated to each other. You know?
Okay, point taken. So maybe we need to focus on developing AI systems that can work collaboratively with humans, where the AI provides suggestions and insights, but the human retains ultimate control over the reasoning process, like a chess-playing AI that offers suggestions, but the human player makes the final moves.
That's a good analogy. A collaborative approach could leverage the strengths of both humans and AI. Humans excel at abstract reasoning, critical thinking, and common sense knowledge, while AI excels at pattern recognition, data analysis, and processing large amounts of information.
But to make that collaboration effective, we need to find ways to bridge the gap between human and AI reasoning. We need AI systems that can explain their reasoning in a way that humans can understand and that can take human feedback into account. This may mean that we need to add symbolic reasoning to the model instead of only focusing on numerical values.
And that means developing AI systems that can represent knowledge in a way that's both flexible and interpretable. We need to move beyond the black box of deep learning and create AI systems that can reason about the world in a way that aligns with human intuition and understanding. How can a language agent aid humans with theoretical physics if the language agent lacks the ability to translate between the coordinate frames of the mathematical equations?
So where does that leave us with this reasoning language model's blueprint? Are we saying it's fundamentally flawed?
Not necessarily flawed, but perhaps incomplete. I think that scaling up language models and tweaking their architecture can lead to some incremental improvements in reasoning abilities. But I don't think it's going to get us to true AGI. We need a more fundamental breakthrough in how we represent knowledge and how we enable AI systems to reason with that knowledge.
I agree. The blueprint is missing the key ingredient, a robust mechanism for translating between different coordinate representations. Without that, these models will always be limited in their ability to understand and reason about the world. We need coordinate frame translation.
Okay, but what are the alternatives? What other approaches should we be exploring?
Well, as Sarah mentioned earlier, neuro-symbolic AI is one promising direction. This approach combines the strengths of neural networks and symbolic reasoning. Neural networks can be used for pattern recognition and learning from data, while symbolic reasoning can be used for representing knowledge and performing logical inference. This can lead to a more interpretable AI.
Exactly. And I think that neuro-symbolic AI is particularly well suited for domains where we have a lot of structured knowledge, such as mathematics, physics, and logic. In these domains, we can use symbolic reasoning to represent the underlying principles and rules, and then use neural networks to learn how to apply those principles to specific problems.
But isn't neuro-symbolic AI much more difficult to develop than deep learning? It requires us to manually encode knowledge and rules, which can be a time-consuming and error-prone process.
That's true, but there's also research into techniques for automatically extracting symbolic knowledge from data. For example, we could use neural networks to learn the underlying rules of a game and then represent those rules symbolically. This could allow us to build neuro-symbolic AI systems without having to manually encode all the knowledge.
The question becomes, how can we extract knowledge and rules from a dynamic, spatiotemporal world? My focus would be on systems that can learn to represent and manipulate information in different coordinate systems. Imagine an AI system that can seamlessly switch between spatial, temporal, and abstract representations of a problem. That would be a huge step forward.
So it sounds like we all agree that the reasoning language model's blueprint is a good starting point, but it's not the whole story. We need to explore other approaches, such as neuro-symbolic AI and spatiotemporal reasoning, to truly unlock the potential of AI.
Precisely, and I think that the future of AI will involve a hybrid approach, where we combine the strengths of different techniques to create systems that are both powerful and interpretable. Language agent plus a strong symbolic representation.
Yes, and we need to be mindful of the ethical implications of AI. We need to ensure that AI systems are used in a way that benefits humanity and that they don't exacerbate existing inequalities or create new ones.
And we need to be careful about placing too much trust in AI. We need to remember that AI systems are not perfect and they can make mistakes. We should use them as tools to augment our own intelligence, not as replacements for it. So, what about future directions?
From my perspective, I'd love to see more research into combining language agents with neuro-inspired algorithms. Can we use language models to analyze vast amounts of theoretical physics literature and then use that information to design more biologically plausible algorithms? I mean, could a language model even parse the complexities of general relativity and offer insights into how the brain handles abstract concepts?
I'm still focused on scaling up. I want to see what happens when we train even larger language models on even more data. Maybe we'll discover some emergent properties that we can't even imagine right now. I think figuring out how to quantify the reasoning ability of these models is crucial. We need more than just task completion metrics.
I want to see more real-world applications of neuro-symbolic AI. I'm tired of theoretical papers and small-scale experiments. Let's see if we can use neuro-symbolic AI to solve some challenging problems in domains like medicine, finance, or engineering.
My focus is on spatiotemporal reasoning. I want to develop AI systems that can understand and reason about the dynamic interaction of different coordinate systems. Can we create specialized modules that translate between physical coordinates and abstract concepts? That's where I see the biggest potential for breakthroughs.
That's a great set of directions. I think we all agree that the path to AGI is going to be long and winding, but it's an incredibly exciting journey.
Absolutely. And it's important to remember that AI is not just about building intelligent machines. It's about understanding intelligence itself, both artificial and natural. So, with that, I am going to wrap it up. Thanks for listening, and we'll see you next time on Cognitive Spirals.
Thank you for listening.